Derive and apply T formula. So another name for T formula is half angle formula. And what does that mean? So if we look at, for example, cos 2 theta, the half angle version of this would just be cos theta, because theta is half of 2 theta. So when we write our expressions for our double angle formula, for example, sine 2 theta, we get 2 sine theta cos theta. And here, our expressions on the right-hand side are half of the angle of 2 theta. And we're going to use these to get some nice expressions. So let's write our cos 2 theta formula, which is just cos squared theta minus sine squared theta. And again, our theta is a half of the original angle. And tan 2 theta equals 2 tan theta over 1 minus tan squared theta. And again, our thetas are expressed in half of what they originally were. Now, here, we're going to let 2 theta equal theta on our left-hand side. So we're going to get sine theta. Now, if this is half of this angle, we should be able to write these as 2 sine theta over 2 times cos theta over 2. Cos theta could be written as cos squared of theta over 2 minus sine squared theta over 2. And tan theta as 2 tan theta over 2 over 1 minus tan squared theta over 2. And these are the basis for our half angle formulas. But why is it called T formula? Well, it's called T formula because we're going to let T equal tan theta over 2, because we get some nice results when we do this. And if we let T equal tan theta over 2, we could express this in terms of a right angled triangle, where if we let this angle here equal theta over 2, to get an expression for tan theta where tan theta over 2 equals T, we know tan is the ratio of the opposite over the adjacent side. So our opposite side would have to be T, and our adjacent side would have to be 1 in this case, because T over 1 would give us T. Then using some simple Pythagoras, we can get the hypotenuse as 1 squared, which is 1 plus T squared, all square rooted for our hypotenuse. Which would mean that we can get expressions for cos theta over 2 and sine theta over 2. So let's go ahead and do that. So we can say that cos theta over 2 equals our adjacent side over the hypotenuse, so 1 over the square root of 1 plus t squared. And sine theta over 2 would be the opposite side, which is t over the hypotenuse, which is the square root of 1 plus t squared. And now we can go ahead and sub in tan theta over 2 as t over here. Cos theta over 2 is all this over here for cos theta over 2, and sine theta over 2 in terms of t over here for all our expressions for sine theta over 2. So for sine, we're going to get sine theta equals 2 times sine theta over 2, which we now know is t over square root of t plus 1 plus t squared, all square rooted. Cos theta over 2 is 1 over root 1 plus t squared, all square rooted. And multiplying this all out, we times our numerators together. 2 times t times 1 is just 2t over the square root of 1 plus t squared times the square root of 1 plus t squared. The roots cancel out and we just have 1 plus t squared. And this is our first formula to express sine theta in terms of a half angle where t is equal to tan of theta over 2. So this successfully gives us an expression when we have some angle and we can express it in terms of half of that angle. So let's go ahead and do the same thing for cos theta. Because that's going to be cos theta over 2 squared. So we know cos theta over 2 is 1 over the square root of 1 plus t squared minus sine theta over 2 squared. So it should be squared. So we get t over square root of 1 plus t squared, all squared. Now this is going to give us 1 over the square and the square root will cancel out, so we get 1 plus t squared minus t squared is just t squared over the square root and the square are going to cancel out, so we get 1 plus t squared. So we're going to get our final expression for cos theta, because these have the same denominator, so we can just subtract the numerators and get 1 minus t squared, and that's our expression for cos theta. And doing the same for tan, well, we know that tan theta over 2 is just directly equal to t. So this is an easy one. We're just going to get 2t over 1 minus t squared for tan theta. And these are all our expressions for our half angle formula or our t formula. So how can we go ahead and use these in some examples? So let's look at an example where we know tan theta equals 5 over 12, and we want to find sine 2 theta. Well, here we have theta and 2 theta, where theta is half of 2 theta. And whenever we can recognize that, we should be thinking about t formula. If it makes it easier, you could let 2 theta equal alpha, which would then imply that theta equals alpha over 2. So we'd actually have an expression that says tan alpha over 2 equals 5 over 12. And we want to find sine alpha. And here it's probably even more obvious that we have a half angle result where we can use t formula. Because we know with t formula, if t equals tan of alpha over 2, we can use all our expressions for t formula. So we know that sine alpha is 2t over 1 plus t squared, as long as t is equal to tan alpha over 2, which it is. And in this case, we know the value of t. It actually equals 5 over 12. So we can just go ahead and sub that in. So our value for sine alpha is going to be 2 times 5 over 12 over 1 plus 5 over 12 squared, which is just going to be 5 over 6 all over 1 plus 25 on 144, which is going to be 5 over 6 all over 169 over 144. And simplifying this is just going to give us 120 over 169. Let's look at one more example. So here we want to prove that cos theta plus sine theta minus 1 all over cos theta minus sine theta plus 1 equals tan theta over 2. And again, hopefully we can recognize that when we have expressions for theta and theta over 2, that T formula can work here. So we know if we let tan theta over 2 equal T, we can use all of our T formula results. So we can go ahead and sub in all our T formula results for cos theta and sin theta here. So cos theta is 1 minus T squared over 1 plus T squared. Sin theta is 2T over 1 plus T squared minus 1 all over cos theta, which is 1 minus T squared over 1 plus T squared, minus sin theta, which is 2T over 1 plus T squared plus 1. And we want to show that it all equals T when tan theta over 2 equals T. So let's just take our left-hand side. It's a bit of a mess, and tidy it up a bit. So I'm actually going to rewrite 1 as 1 plus T squared over 1 plus T squared. And same with this one here, 1 plus T squared over 1 plus T squared. Because now every term will have the same denominator. So we're going to get everything over 1 plus T squared in our first part up here. And we'll just add all those numerators together, where we have 1 minus T squared plus 2T. Now we're minusing all the terms here, so we're going to get minus 1 minus T squared. And that's going to be all over. You can do the same thing. So it's going to be 1 plus T squared, and we'll just add and subtract all those terms in the numerators now. So we'll have 1 minus T squared minus 2T plus 1 plus T squared. So let's simplify this. So we've got 1 minus 1 is going to go, minus T squared is going to be minus 2T squared, and then we've got the plus 2T. That's going to be all over 1 plus T squared, all over. Now in this second fraction, we've got 1 plus 1, which is 2. We've got minus T squared plus T squared, which is going to cancel, and then we've got the minus 2T. And that's all over 1 plus T squared. So whenever we have two fractions on top of each other, we can think about the outer two multiplied together over the inner two multiplied together. So let's fix that up. So we'll have 1 plus T squared times minus 2T squared plus 2T all over the inner two multiplied together, 1 plus T squared times 2 minus 2T. The 1 plus T squareds will cancel out. Let's factorize out 2T in the numerator. So we'll factorize out 2T. So we're left with 1 minus T in the numerator. Now let's factorize out 2 in the denominator. And we're left with 1 minus T. The 1 minus T's will cancel. The 2's will cancel. And we're left with T. And that's exactly what we wanted on the right-hand side. So it equals the right-hand side.